Right now, as you listen to these words, you may feel as if you're in one single, solid version of reality. A linear path where every choice leads to a clear consequence, every event has a cause, and your life moves forward in one straight line. But quantum physics suggests something far stranger. According to the laws governing the tiniest building blocks of the universe, you may not be in just one version of your life. In fact, there may be countless others, running side by side with this very moment. In another possibility, you never clicked on this video. In yet another, you clicked on it but stopped halfway through. Somewhere, perhaps, you're listening to this with different thoughts, a different perspective, or even in a different mood. These aren't mere hypothetical fantasies. They are serious implications of what quantum mechanics is quietly whispering to those who dare to listen closely. The fabric of our reality may not be a fixed, solid structure. It might be more like a shimmering field of overlapping potentials. Quantum superposition, wave-particle duality, and the strange phenomena observed in subatomic behavior suggest that the universe doesn't simply settle on one outcome. It teeters between possibilities, and only in the presence of observation do those potentials collapse into the version we call real. But if that's true, then what happens to all the other possibilities that didn't get picked? Do they vanish? Or do they continue elsewhere, playing out like parallel threads of reality? This video isn't just about understanding quantum mechanics. It's about confronting the strange, uncomfortable, and exhilarating idea that the life you think you know might just be one of many. We'll explore the mind-bending nature of quantum superposition, uncover the eerie implications of entanglement, and question what it truly means to be a conscious observer in a universe filled with probabilities instead of certainties. And here's the core question we'll wrestle with. Are you really living just one version of your life? Or is every possibility you've ever imagined playing out in another layer of existence? This question touches not only physics but identity, choice, and existence itself. Prepare to challenge everything you think is concrete. The laws that apply to the grand stage of your everyday life may not be the laws that rule the quantum world beneath it. And if that hidden world holds the key to multiple realities, your place in the cosmos may be far more dynamic, mysterious, and powerful than you ever considered. Let's begin. Throw a ball at a wall and it bounces back. Simple, predictable, and easily explained. But replace that ball with an electron, and something strange begins to happen. Sometimes, instead of bouncing back, it appears to pass right through the wall. No cracks, no holes, no magic tricks. Just physics behaving in a way that defies every expectation rooted in classical understanding. Welcome to quantum mechanics, where the rules that govern subatomic particles seem to operate under a completely different code. One where certainty becomes probability, and objects don't seem to settle into a single state until someone observes them. One of the most iconic experiments in quantum physics is known as the double-slit experiment. This is not just a quirky laboratory test. It's the doorway into a reality that is far stranger than fiction. In this experiment, when particles such as electrons are fired at a barrier with two slits, something fascinating happens. If no one is observing the experiment, the electrons don't behave like little solid marbles. Instead, they interfere with themselves, creating a pattern on the detector screen that resembles waves, ripples that suggest each electron is somehow going through both slits at the same time. That's right, not one slit or the other, but both. The same electron acting like a wave, as if it had split and taken every possible path. But here's where it gets even stranger. The moment someone observes the electrons, just watches which slit they go through, that wave-like behavior disappears. Suddenly, the particles act like tiny marbles again, choosing one slit and one path. The interference pattern vanishes. It's as though the act of observation itself collapses the multiple possibilities into one outcome. This phenomenon isn't a minor anomaly, it's a foundational mystery. At the heart of it is wave-particle duality, the idea that particles like electrons and photons behave both like particles and like waves, depending on how they are measured. It's not just that we don't know which state the particle is in until we observe it. It's that it literally does not settle into one until the observation happens. The implications of this go far beyond physics labs. They raise profound questions about the nature of reality itself. Is the world fundamentally probabilistic? Does reality only solidify when it is being measured? And what does that mean for everything that exists unobserved? This is where quantum superposition comes in. In simple terms, it's the concept that a particle doesn't exist in one specific state or place. It exists in all possible states simultaneously, each with a probability. Only when it is observed does it appear to choose one. In this superposition state, an electron isn't just here or there. It's both here and there until it's forced to pick. Superposition isn't a rare or exceptional occurrence. It's the default state of quantum systems. In fact, everything you see around you, from atoms to molecules, is governed by these same rules at a foundational level. The reason chairs don't appear in two places at once, or people don't blur into multiple locations, is not because superposition doesn't apply, but because the complexity and interactions at larger scales tend to mask it. But understanding the quantum world requires unlearning many assumptions. Classical thinking teaches that things exist in definite states, that objects have fixed positions, and that reality follows a tidy cause and effect path. Quantum physics unravels that picture, showing us a realm where particles are probability clouds, where uncertainty is built into the fabric of existence, and where outcomes are shaped not just by forces, but by whether or not someone is looking. The unsettling part is this: if the smallest components of reality behave this way, then the world built from them might also carry echoes of this uncertainty. The rules of quantum physics do not just apply in tiny hidden corners of the universe. They are the very scaffolding on which the universe is built. This doesn't just challenge our knowledge of physics. It demands a rethinking of what it means to know anything at all. When reality itself waits for an observer to choose a path, the observer becomes a part of the equation. Observation is not passive, it plays a role in shaping the outcome. That's not a philosophical metaphor. That's what the math says. And now the most haunting realization begins to take form. If particles exist in multiple states until observed, then every possibility they represent is just as real as the one we end up seeing. Every version of reality, every possible path, is real in its own right, waiting to be collapsed by an act of observation. This is not just scientific curiosity, it's a direct confrontation with the boundaries of what we think is real. When the foundations of the universe are built on uncertainty, fluidity, and multiple simultaneous possibilities, the world you thought you knew starts to look like just one version among many. So, the next time you hear someone say, "This is how the world works," remember this. At its deepest level, reality doesn't work the way we were taught. It operates on probabilities, possibilities, and hidden patterns that only become solid when someone is there to see them. And if every particle is part of a probability web, then perhaps your life, your choices, your moments, your path, is part of a much larger, more intricate tapestry of potential. The question now isn't whether the quantum world is strange. It's whether our understanding of reality has always been too narrow to see the full picture. There's a thought experiment that's become almost legendary in quantum physics discussions. A strange tale involving a cat, a box, and a paradox that forces us to question what reality truly is. It's not just about the fate of a feline. It's a deep philosophical riddle wrapped in scientific principles. And it's warning us that our basic assumptions about existence might be incomplete. That experiment is known as Schrödinger's cat, and it was proposed not as a solution, but as a dramatic illustration of the bizarre implications of quantum superposition. Here's how it works. Imagine a sealed box containing a cat, a tiny amount of radioactive material, a Geiger counter, a vial of poison, and a trigger mechanism. If the radioactive atom decays, the counter detects it, the vial breaks, and the poison is released, ending the cat's life. But here's the twist. The atom's decay is a quantum event. Until it is observed, it is both decayed and not decayed at the same time. That means, until someone opens the box, the cat is considered both alive and dead simultaneously. It's a brutal image, but its point isn't about the cat. It's about the absurdity of quantum rules when applied to everyday objects. In the quantum world, particles can remain in superposition until observed. So, does that same principle apply to larger systems made of particles? If so, is the cat genuinely suspended between life and death, a blend of two contradictory states until the moment the box is opened? This isn't just a theoretical puzzle. It highlights a fundamental problem known as the measurement problem, a question that physicists still debate to this day. The dilemma centers on this: why does observation seem to collapse a system from multiple probabilities into one actual outcome? And perhaps more importantly, what qualifies as an observer? Is it a conscious being, a machine, or just any interaction that disturbs the system? The rules of quantum mechanics suggest that particles remain in superposition until measurement occurs. But no one truly knows where the boundary lies between the quantum world of possibilities and the classical world of definite outcomes. That boundary is blurred, undefined, and possibly non-existent. Some interpretations suggest that everything, including large objects, could exist in superposition, but interactions with the environment, decoherence, make the multiple possibilities vanish into the background, unnoticed. This leads us deeper into the role of the observer. In quantum physics, the observer is not a passive onlooker. Instead, the observer is a force that changes the system by interacting with it. This is known as the observer effect, a phenomenon where the very act of measurement alters the outcome. It challenges the old idea of objective reality being independent of human consciousness. Suddenly, the observer becomes entangled in the system they are observing. Speaking of entanglement, another strange and unsettling concept arises from the quantum realm: quantum entanglement. This is a phenomenon where two or more particles become linked in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. Separate one particle by miles, light years even, and the moment you measure one, the other adjusts its state instantaneously. Einstein famously referred to this as spooky action at a distance. He was skeptical, believing that there must be hidden variables we didn't yet understand. But over time, repeated experiments have confirmed entanglement is real, measurable, and consistent with quantum predictions. It isn't science fiction. It's one of the most well-tested phenomena in quantum physics. This interconnection defies classical logic. Nothing should travel faster than light, and yet, entangled particles seem to communicate across space with no delay. But it's not information being sent, it's correlation. Still, it implies a strange underlying unity beneath the surface of reality, where distance loses its meaning and individuality fades into shared quantum states. Now, if subatomic particles can exist in multiple states simultaneously, superposition, and influence each other across vast distances, entanglement, what does that say about the structures built from those particles? What about molecules? Cells? Organs? Brains? Humans? Are we, too, subject to the rules of superposition? Are there multiple versions of each of us, suspended in different potentialities, waiting to be collapsed into a particular state through some observation we don't fully understand? This isn't just speculative pondering. It's a reflection of quantum logic applied to macroscopic systems. The only reason you don't appear in a fuzzy blur of overlapping states might be because the complexity of your body interacts constantly with the environment, producing quantum decoherence. It's as if the larger the system becomes, the more its superposition states get drowned out in background noise. But the underlying quantum behavior doesn't disappear. It merely becomes hidden beneath a veil of classical outcomes. So, while you may appear solid, definite, and indivisible, the truth may be more layered. Beneath that surface lies a realm of shadowed probabilities, constantly branching and fluctuating. You might think your path is fixed, but beneath your conscious experience could be a sea of alternate trajectories, moments where a different decision, a different thought, or even a different quantum event might have led to a different outcome. Superposition, then, isn't just a concept reserved for particles in a lab. It's a profound principle that challenges the very core of identity and existence. If every particle in your body has the capacity to exist in multiple states, it raises the possibility that you are more than just a single thread through time. You might be a sum of many probabilities, a dynamic system perpetually selecting one reality over countless others. And this brings us to a crucial turning point. The moment you accept that superposition is not an oddity but a foundational property of nature, the next step becomes unavoidable. If reality operates on probabilities at its most basic level, then the universe might not be singular at all. It might be a constantly branching structure, one where every possibility continues somewhere, and every outcome is realized in its own version of existence. This leads us into the heart of one of the most provocative theories in quantum physics, a theory that reshapes how we view our decisions, our lives, and even our destiny. But before that, let's sit with this idea a moment longer. The cat in the box was never just a paradox. It was a mirror, reflecting our inability to accept a world that doesn't follow straight lines. The measurement problem wasn't just a technical issue, it was a philosophical revolution, reminding us that the act of observing the universe makes us participants, not spectators. And entanglement wasn't just a curiosity. It was a whisper from the fabric of reality, telling us that separation may be an illusion. So where does that leave us? Right at the edge of a realization that has enormous implications. If reality is a superposition, then your life may not be a fixed narrative, but one possible outcome among many. The next version of you, in another probability layer, might be living a completely different story. And that brings a strange kind of awareness, the knowledge that possibility itself is not just theoretical but real. Everything you are, everything you've experienced, everything you've chosen, might be the result of one path selected from an infinite field of quantum branches. And each time you wonder what life might have been like had you done something differently, the quantum world may already have an answer. But how do these possibilities play out? Do they vanish when not chosen? Or do they continue on, equally real, equally valid, just not within your current experience? That's the question the next concept will challenge us to confront. Because the idea of superposition doesn't stop at particles or even cats in boxes. It may extend to every possible version of reality itself. And if that's true, then we're not just speaking of quantum quarks anymore. We're talking about the structure of existence itself, not as a single thread, but a woven tapestry of endless paths. Ready to hear what that tapestry looks like? Think back to the last time you made a decision. It might have seemed small, a split-second choice, almost trivial. Maybe you picked tea over coffee. Maybe you turned left instead of right. But according to one of the most radical interpretations of quantum physics, that moment didn't just pass. It split the fabric of reality. A new version of the universe was born, one where you made the other choice, one where the alternate path wasn't erased. It simply branched off, continuing without you, but still just as real. This isn't fantasy. It's the core idea behind the many worlds interpretation, proposed by physicist Hugh Everett in 1957. It was more than a theory. It was a challenge to everything we thought we knew about existence. At its heart, it proposed something stunning. When a quantum system appears to collapse into one outcome, it doesn't truly collapse at all. Every possible outcome plays out, each in its own newly formed universe. In traditional quantum mechanics, especially under the Copenhagen interpretation, a particle exists in multiple states until it's observed, at which point the wave function collapses, and one result becomes reality. The observer decides the outcome. This collapse is mysterious, unprovable, and philosophically unsettling. Everett rejected this collapse entirely. He proposed that the wave function, the mathematical description of all possible states, never collapses. Instead, it continues to evolve deterministically. When a measurement occurs, all outcomes happen, but not in one universe. The universe branches, and each branch carries one outcome. The observer also branches, experiencing only one reality, unaware of the others that also continue to unfold. So when you flip a coin, both heads and tails occur. You just only experience one. But in another reality, your counterpart experienced the other. You didn't see that coin land differently. You simply became the version of yourself that did. This view changes everything. In the many worlds framework, you don't live in one reality. You're entangled with an infinite web of them, each created by quantum decisions. Every action, every measurement, every flicker of uncertainty spawns countless new timelines. The universe doesn't choose, it multiplies. This removes the strange need for wave function collapse. The math remains intact. The probabilities remain pure. Nothing vanishes. Nothing is erased. Reality just expands, exponentially, perpetually, endlessly. And this idea leads to a stunning realization. All possibilities exist. Not metaphorically, literally. Every version of events, every alternate history, every forgotten choice has a home in some branch of the cosmos. Think about the implications. Somewhere, there's a version of you who took a different job, loved a different person, never moved to that city, never watched this video. Those lives aren't figments of imagination. They're mathematical consequences of a branching universe. But how do these branches form? What mechanism divides the timelines? The answer lies in something called quantum decoherence, a concept that bridges the quantum and classical worlds. In essence, decoherence explains how quantum systems, when interacting with their environment, begin to lose their coherent superpositions. It's not a collapse. It's a spreading, like ink diffusing into water. The quantum states still exist, but they become inaccessible to each other, no longer capable of interference. In practical terms, they become separate branches of reality, each evolving independently. So when a quantum decision occurs, when an electron spins up or down, when a photon passes or reflects, each possible result becomes part of a separate decohered branch. The more complex the system, the faster decoherence happens. That's why quantum phenomena are hard to observe at larger scales. The branching still occurs, but each version becomes isolated in its own world. In Everett's interpretation, there is no single timeline. There is no privileged version of events. There is only a universal wave function, encompassing all realities at once. You, the observer, are part of that wave function. You are constantly branching, constantly splitting. Each moment a fork in the road, each choice a new path. And here's the most unsettling part. Every version of you is just as real as you are right now. Not imaginary, not hypothetical, real, conscious, living. Each version feels like the one true you. Each one believes they're the original. But in truth, there is no original. Just branches. Just probabilities realized. This isn't a comforting idea for everyone. It removes the special status of your current path. It dissolves the notion of singular destiny. It suggests that you are not the product of one linear life, but a node in a vast tree of infinite selves, all valid, all unfolding. Yet for others, it's a deeply liberating concept. It means there is no singular failure, no definitive mistake. Every choice you didn't make still lives somewhere. Every dream you didn't pursue was realized by another you. Every version of success and growth is out there, branching off from every moment of indecision. And this brings forward a question that's impossible to avoid. If all outcomes are real, do your choices still matter? Many argue that they matter more than ever. Because even if all realities exist, your awareness, the stream of consciousness you are experiencing, is tethered to one path at a time. You are here now in this specific version. Your experience is the only one you're conscious of. Your choices determine which direction that path moves. You don't control the other branches, but you do shape the one you're walking. It reframes the idea of agency. You're not the only version of yourself, but you are the one responsible for this branch, this moment. And even if infinite yous exist elsewhere, only one is living this precise timeline. This interpretation also touches something deeper, something spiritual in its structure. While it arises from strict quantum physics, many worlds begins to mirror ancient philosophical ideas. The multiplicity of existence, the illusion of singularity, the endless reflection of the self. Some see echoes of reincarnation, parallel consciousness, or divine omnipresence. But unlike mysticism, this is built on physics, on equations, probabilities, and logic. Still, critics remain. Many physicists find the idea extravagant. They ask, if these alternate worlds exist, why can't we interact with them? Why don't we see their effects? But the answer lies in decoherence, the barrier that separates them. The branches aren't ghostly, they are fully real, but inaccessible. Like paths in a maze you didn't take, they're not gone, they're just not visible from where you stand. And yet, some theorists propose that subtle interference effects might one day offer hints of these other branches. If technologies advance, perhaps experiments can be designed to detect faint echoes of alternate realities. Until then, the theory remains mathematically sound but empirically elusive. Still, it offers one of the most elegant solutions to quantum puzzles. No special observer required. No mysterious collapse. Just the universe doing what it's always done. Expanding, evolving, branching. And you, standing in this moment, are the witness to one path among infinite others. But you are not alone. Your alternate selves are walking their own paths, each one thinking, feeling, choosing just like you. Each one believing they are the center of their own story. The question then becomes not whether these worlds exist, but what it means for you, the one who's aware of this one. Because even if infinity surrounds you, this moment is yours alone to live. So far, the conversation has orbited around equations, particles, interpretations, and theoretical branches. But there comes a point where theory collides with meaning, where science touches the soul. That's where the implications of quantum mechanics, especially the many-worlds interpretation, move beyond the laboratory and begin to rattle the foundations of identity, choice, mortality, and existence itself. The question presses in with quiet intensity. If every version of your life is playing out somewhere in the quantum multiverse, what does that say about the one you're living now? Start with free will. In a world where every possible decision you could make is played out in some parallel branch, is the notion of choice merely an illusion? Are you making a decision, or are you simply becoming aware of one version of yourself who made it, while another version of you made the other? This challenges one of the deepest assumptions humans hold, the idea of volition, of control, of steering one's path through time. If all outcomes exist, did you really choose anything? Or did reality simply segment itself into pathways where each option was selected by one version of you? It seems paradoxical. Yet, in this framework, free will doesn't disappear, it transforms. It becomes a filter through which your conscious stream moves, selecting one thread of experience out of countless possibilities. You are not the generator of every reality, but you are the experiencer of one. Your choices matter not because they eliminate alternatives, but because they define the sequence of awareness you will inhabit. In this view, responsibility doesn't vanish, it intensifies, because the only you that you'll ever consciously know is this one. You might intellectually understand that somewhere or another you made a different choice, but that path is sealed off from your perception. This is the timeline you inhabit. This is the reality that will carry the weight of your decisions. And that makes your actions meaningful, not because they erase alternatives, but because they sculpt the future you'll walk. But this naturally leads to a more unnerving thought. If multiple versions of you exist, which one is truly you? Here, identity becomes a fractured mirror. Every choice, every divergence creates a new version of you, similar, yet different. Are they all you? Are they merely variations, or independent entities with their own consciousness and autonomy? In traditional thinking, you are a singular being, a unique stream of thought and experience. But the quantum lens reveals something different. Identity becomes probabilistic, branching, fluid. Each version of you believes itself to be authentic. Each feels ownership over its choices. Each walks forward thinking it is the central thread. Yet no single version holds primacy. There is no master copy. No original soul duplicated in fragments. Each version is equally valid, equally complete, equally real. This concept destabilizes the idea of the self as a fixed entity. It reframes consciousness as a localized spotlight within a broader landscape of possibility. You are not a static point. You are an unfolding pattern within a vast quantum field of identities. The you watching this now is one pattern. Others exist beyond reach, but not beyond existence. And then comes the most haunting idea of all: quantum immortality. This is a thought experiment, not a theory of science, but it carries weight precisely because of how it rides the logic of the many worlds framework. It begins with a simple premise. If every possible outcome occurs somewhere, then there exists a branch in which you always survive. No matter the danger, no matter the odds, there is always a version of you that continues. In some worlds, you die, but your consciousness, from your perspective, might always find itself on the branch where survival continues. This leads to an unsettling implication. You may never experience your own death. From your point of view, the narrative of your life never ends because somewhere, somehow, your awareness always shifts into the branch where you continue living. Now, this isn't a guarantee of eternal youth or physical invincibility. In most branches, your life would unfold normally, with all its fragility. But in the infinitesimal subset of branches where unlikely survivals occur, consciousness may persist. The idea stretches the edge of plausibility, but it highlights something deeper. The quantum world challenges the finality of endings. It suggests that death, like all events, is not singular but distributed across a spectrum of probabilities. Still, caution is needed here. This is not a promise of eternal life. It's not an escape from mortality. It's a philosophical mirror reflecting the nature of awareness in a branching cosmos. It raises the unsettling possibility that you are always the version who survives, even if survival becomes increasingly improbable. Whether one accepts that idea or not, it opens a profound discussion on the nature of meaning itself. If infinite versions of your life exist, does that dilute your value? Does it make your experience trivial, just one among billions of alternatives? Not necessarily. In fact, it may elevate it, because what you are experiencing now is singular, unique in its combination, irreplaceable in its moment. The existence of other realities doesn't negate your own. It expands the canvas of possibility. But only this version of you is aware of this experience, in this time, with these thoughts. And therein lies the core paradox. Your life is both one among countless and yet absolutely irreplaceable. It is not contradiction, it is quantum reality. Multiplicity without duplication. Infinity without erasure. And this leads to a final, piercing insight. Meaning is not found in exclusivity, it's found in awareness. You are here, conscious in this thread of existence. That alone gives it weight. The choices you make echo through this branch. The thoughts you have ripple through this life. The meaning you create belongs not to a hierarchy of realities, but to the moment you are living now. Quantum mechanics doesn't strip life of significance. It magnifies it. It places you in a universe that is alive with possibility, branching in every direction, yet grounding your consciousness in one moment of unfolding reality. The universe is not cold or deterministic. It is wide, wild, and rich with patterns. And you are one of those patterns, unrepeatable, aware, and choosing. So when you next pause before a decision, remember, all outcomes may exist somewhere, but only one will carry your awareness forward. That's not cause for despair. It's a call to mindfulness, a reminder that this moment, this thought, this path matters. Because regardless of how many other versions of you exist, only you can live this version now. The mysteries of quantum physics have sparked a profound shift not only in how we view reality, but also in how we talk about it. And in that shift, something curious has happened. A fusion of scientific insight and mystical interpretation that has blurred the lines between rigorous inquiry and speculative belief. It's time to draw that line clearly and examine what's real, what's misunderstood, and what's simply fiction wearing the mask of science. When people hear about particles existing in multiple states, or the idea of infinite realities, it's no surprise that imaginations run wild. Quantum mechanics, by its very nature, defies our ordinary logic. But with that defiance comes a temptation, a pull to extrapolate beyond what the science actually tells us. And that's where confusion begins. Let's start with the most common leap. The belief that because particles exist in superposition, human thoughts can influence or alter the fabric of the universe just by intention. It's a seductive idea that your consciousness is not just observing reality, but creating it. That thoughts are somehow quantum waves interacting with the universe itself. That you, simply by thinking a certain way, can bend reality to your will. This belief often draws on the concept of the observer effect. After all, in quantum mechanics, it's true that observation seems to influence the outcome of experiments. But here's where the misinterpretation begins. In physics, observation doesn't mean human attention. It doesn't mean awareness, intention, or belief. It means measurement interaction between particles and instruments that collapses a quantum state into a defined outcome. It's a mechanical, measurable interaction, not a metaphysical one. But that distinction is often lost when these ideas are translated into popular culture. Phrases like "you create your own reality" are taken literally, not metaphorically. The science is stretched beyond its boundaries, and suddenly, people believe that their desires or affirmations can physically reshape quantum fields. The logic collapses, but the allure remains. Then there's the concept of quantum consciousness, a theory that proposes the brain itself operates on a quantum level, and that consciousness arises from quantum processes in the brain's microstructures. This idea, while fascinating, is speculative at best. No direct evidence supports it, and most neuroscientists argue that the brain operates at scales and temperatures that are incompatible with the fragile states required for quantum superposition. The quantum world is delicate. It's governed by probabilities, by uncertainty, by entanglement and coherence. But these effects, while spectacular, operate at subatomic levels. When you scale up to molecules, cells, or brains, those effects typically vanish. That's because the world we live in, full of air molecules, light, heat, and countless interactions, is hostile to the subtle dynamics of quantum states. It's not that quantum effects stop existing, it's that they become drowned out by the noise of the macroscopic world. That's known as decoherence. It's the reason why particles can remain in superposition in isolation, but collapse into a defined state as soon as they interact with their environment. And that environment, in human terms, is overwhelming. You are a system composed of trillions of atoms, immersed in a planet full of other complex systems. The idea that your mind operates like a quantum computer, maintaining entangled states and influencing probabilities, is simply not supported by the physics. Still, the belief persists. Why? Because it offers something irresistible, a sense of control. It suggests that reality is not indifferent, but responsive. That thought itself holds power. That we are not just subjects of the universe, but co-creators of it. And while that may be empowering on a metaphorical or philosophical level, it's not how the mathematics of quantum mechanics works. Another distortion arises from attempts to link quantum mechanics with spiritual traditions. Ancient philosophies from the East are sometimes retroactively framed in quantum terms, with claims that Vedic scriptures or Taoist texts anticipated quantum principles. These associations, though poetic, are often superficial. They rely on metaphor, not on methodological correlation. Yes, both quantum physics and mysticism explore the nature of reality, and both challenge surface appearances. But the methods are fundamentally different. One is empirical, experimental, and precise. The other is experiential, symbolic, and interpretive. They may converge in their mystery, but not in their mechanisms. It's also important to address the popular misconception that the strangeness of quantum mechanics grants license to believe anything. That because the universe is bizarre at the quantum level, all boundaries dissolve. That all ideas, no matter how unprovable, are equally plausible. This is a mistake. Quantum theory is strange, yes, but it is not a free-for-all. It is governed by equations, by constraints, by predictive power. The oddity does not mean chaos, it means unfamiliar structure. There is a reason physicists work for decades to test the tiniest quantum effects. The theories are not just vague suggestions. They are precise models that make exact predictions, and those predictions are confirmed to staggering degrees of accuracy. That's what separates quantum mechanics from pseudoscience. It works. It is not a mystery wrapped in metaphor. It is a framework with measurable consequences. And yet, the human mind seeks narrative. We want more than equations. We want meaning, agency, purpose. That's where mysticism enters, not as science, but as interpretation. It offers a bridge between uncertainty and significance. But we must be careful not to confuse the bridge for the terrain. The real magic of quantum mechanics is not in its mystical reinterpretation, but in its raw, unsettling precision. The fact that a particle can interfere with itself. The fact that entangled particles affect each other across vast distances. The fact that probabilities replace certainties at the most fundamental level. These facts are already more wondrous than most fiction. They don't need embellishment. They don't require spiritual scaffolding to be profound. If anything, the deeper lesson of quantum physics is humility. It shows us that reality is not what we expect, that our senses are poor guides to the foundations of the universe, that beneath the surface of perception lies a realm that follows rules we are only beginning to understand. It doesn't hand us power, it hands us mystery. And in that mystery lies beauty, not control, not wish fulfillment, but awe. So let's not diminish that beauty by turning it into a motivational slogan or a mystical sales pitch. Let's honor it for what it is. A staggering glimpse into the machinery of existence, humbling in its elegance and terrifying in its implications. This isn't to say that quantum theory and philosophical exploration can't coexist. They absolutely can. The ideas of multiplicity, uncertainty, and interconnectedness have deep resonance. They can inspire creativity, contemplation, and a richer view of self and reality. But that inspiration should not come at the cost of clarity. We owe it to the science and to ourselves not to dilute the profound with the fantastical, not to replace rigorous discovery with convenient mythology, not to confuse metaphor with mechanism. Because in the end, the truth is strange enough. The story of quantum physics is far from finished. In fact, the most astonishing chapters may still be unwritten. Right now, researchers around the world are pushing the boundaries of what we know, and more importantly, what we thought we could never know. They're designing experiments not just to observe particles, but to catch reality in the act of becoming itself. And these efforts might shatter the last illusions we hold about what this universe truly is. For decades, quantum theory has been tested in laboratories with precision beyond anything the human mind can intuitively grasp. But now, the focus is shifting. The frontier is no longer just about confirming that quantum effects exist. It's about exploring whether reality itself is structured in a way that's stranger than even the wildest theories have suggested. It's about daring to ask, can we prove the existence of multiple versions of reality, not in metaphor, but in measurable consequence? This isn't science fiction. It's happening now. One of the most fascinating areas of research lies in pushing the boundaries of quantum superposition. Until recently, superposition was something seen primarily in microscopic systems, particles, photons, atoms. But scientists are beginning to explore how far this principle can be stretched. Can entire molecules or even larger structures be coaxed into superposition? Can we make reality itself blur at a scale we can finally notice? And that's not a rhetorical question. In controlled experiments, physicists have already achieved superposition in systems that are significantly larger than individual particles. Certain molecules, composed of hundreds of atoms, have been placed in superposed states and passed through interference patterns. These aren't just tiny waves anymore. These are complex structures exhibiting behavior once thought impossible outside the quantum world. These findings raise a powerful question. Is there a fundamental limit to superposition, or is it just a matter of shielding systems from environmental interference? In other words, do we live in a universe where only the small can be strange, or have we simply not yet learned how to protect the strange in larger things? That's where the next wave of experimentation comes in. Researchers are now devising ultra-sensitive, ultra-isolated systems to test just how large an object can remain in quantum limbo before it collapses into classical behavior. And if they succeed, the implications are staggering. It would suggest that the boundary between the quantum and the classical is not fixed, but artificial. That the line separating your world from the world of multiple possibilities is thinner than you think. Then comes the question of measurement. Traditionally, the measurement problem has sat like a silent riddle at the heart of quantum theory. We know that observation seems to collapse superpositions. But what is observation? Is it a fundamental process? Is it a thermodynamic interaction? Or is it something deeper, perhaps even entangled with consciousness itself? To answer this, researchers are crafting experiments so precise they can delay measurement, or even split it across systems. In recent years, experiments involving delayed choice quantum erasers have shown that even decisions made after a particle passes through a double slit can influence the outcome, almost as if reality retroactively rewrites itself based on the path we eventually choose to observe. These aren't thought experiments. They're actual laboratory setups with results that continue to defy intuitive logic. And now, a new wave of experiments is pushing further, testing whether measurement outcomes can be influenced by quantum entanglement in a way that challenges the very idea of local causality. If proven, it wouldn't just support the many worlds interpretation, it might require it. This brings us to one of the most controversial and exciting arenas: testing the existence of parallel realities through decoherence models. Researchers are designing increasingly clever ways to monitor whether the environment around a quantum system picks up which path information passively, even when no conscious observer is involved. If it does, it confirms that reality is constantly splitting, not because you observe it, but because the universe itself is structured to evolve into branches. One experiment proposed by leading physicists is to isolate quantum systems just long enough to test whether a branching point occurred, by checking interference patterns that should disappear only if multiple realities actually split and decohered. If interference vanishes under the right conditions, it suggests the system has indeed split into outcomes that no longer interact, a direct fingerprint of many worlds' behavior. Of course, confirming this is no small task. It requires shielding systems from even the slightest environmental influence. But each advance in technology brings us closer. And it's not just about abstract knowledge. These experiments have practical consequences, especially in the realm of computing. Quantum computing isn't just another step in computational speed. It's a different species of computation altogether. Traditional computers rely on bits, binary states of 0 or 1. Quantum computers use qubits, which can exist in superposition, effectively operating as 0 and 1 simultaneously until measured. That means they can process complex problems in parallel, exploring vast combinations at once and collapsing into a solution that would take classical systems thousands of years. But here's where it gets truly fascinating. Some interpretations suggest that quantum computers might be tapping into multiple branches of reality to compute results. It's not just a metaphor. If the many worlds interpretation is correct, quantum computation may be leveraging those alternate branches, using them to run calculations that only become real in the branch where the answer emerges. Whether this is metaphor or mechanics is still debated. But either way, quantum computing is a doorway into the future. A future where encryption becomes obsolete, artificial intelligence leaps forward, and scientific modeling reaches levels of complexity previously unimaginable. And it doesn't stop there. Researchers are now exploring quantum networks, systems where entangled particles form the basis of communication that is instantaneous, secure, and theoretically immune to hacking. These networks are already being tested in limited environments. In the near future, entire cities might communicate through quantum channels, where the very laws of nature prevent eavesdropping. The ripple effects will be immense, not just in technology, but in our understanding of reality itself. Each advancement forces us to reconsider what is possible. Each experiment brings us closer to answering questions once considered untestable. But perhaps the most profound change lies not in machines or measurements, but in mindset. As science moves deeper into the quantum frontier, the questions grow larger. We are no longer just asking how things work. We are confronting the very structure of existence. Is there a fundamental substrate from which all realities emerge? Are we witnessing the outer edge of physics, or just scratching the surface of something far deeper? There's also growing interest in merging quantum research with cosmology. Physicists are now examining whether the entire universe at its birth existed in a superposed state, and whether cosmic inflation itself was a kind of quantum branching process. Some models suggest that each bubble of spacetime that inflated into a universe may be just one realization among countless others, all governed by different laws, constants, and probabilities. A literal multiverse, not just in theory, but in consequence. As telescopes become more powerful and sensors more sensitive, we may soon find cosmic evidence that forces us to rethink the singularity of our universe. We may not see other realities directly, but we might observe gravitational or energetic footprints that hint at their influence. And so, the pursuit continues not just in laboratories, but in thought, in theory, in the courage to ask questions that stretch the boundaries of what we thought science could ever reach. The quantum age is not an age of certainty, it's an age of possibility. An age where the old models of fixed reality are giving way to a living, breathing field of probability, interconnection, and transformation. This is not the end of science. It is the rebirth of wonder. Everything you've heard so far is not just a journey through quantum mechanics. It's an invitation to reframe how you think about life itself. Because when you strip away the layers of everyday certainty, when you let go of the comfort of linear logic, something astonishing begins to unfold. Reality may not be what it seems at all. In fact, it might not even be one thing. It might be all things. And you, right now, might be just one version of countless possible selves, experiencing just one version of countless possible lives. Throughout history, humans have wrestled with big questions. Who are we? Why are we here? Is this all there is? But never before has science come so close to answering those questions in ways that don't shrink the mystery, but instead magnify it. Quantum physics has shattered the walls that once divided fact from speculation. And while much of what it reveals may feel foreign, even unsettling, it also presents a rare opportunity to redefine what it means to be alive in a universe this complex. Think again about the concept of superposition. A particle doesn't choose a single path. It holds every path open until forced to settle into one. That's not just a physical curiosity. It's a metaphor written into the structure of reality itself. If at the smallest levels, nothing is ever fixed until interaction defines it, what does that imply about the larger fabric of life? What if the future isn't a single road, but a web of probabilities waiting to crystallize? What if your choices don't just affect what happens, but determine which world becomes your reality? You've also heard about entanglement, how two particles, no matter how far apart, can remain mysteriously connected. Break that down, and it raises something deeply personal. Separation may be an illusion. The universe may be far more unified than our senses allow us to perceive. And if everything is entangled at some level, then perhaps you're never as isolated as you think. Maybe your actions ripple further than you realize, not just across time and space, but across possibilities. Now add the idea of branching realities. The notion that each decision you make doesn't eliminate the other options. It simply places you on a different branch. The others still play out elsewhere. Another version of you took the path you didn't. Another version said yes where you said no. Another version hesitated while you acted. And every moment, the universe reshapes itself into a lattice of unfolding lives. This doesn't make your life meaningless. It does the opposite. It means every moment is charged with unimaginable depth. It means that right now, the very fact you're aware of this version of your life gives it weight, presence, and power. You are not a passive observer of some predetermined fate. You are an active participant in the constant construction of your own branch of reality. It's easy to feel overwhelmed by the vastness of all this. The idea that there could be countless versions of you, countless versions of every person you know, existing in layers of parallel existence. But the point isn't to get lost in those layers. The point is to awaken to the one you're in. Because the strange truth is, the more we learn about how reality works, the more valuable each moment becomes. The more expansive existence seems, the more profound your current place in it becomes. Every breath, every thought, every decision is happening in this specific strand of reality, this precise echo of the quantum multiverse. And while others may exist, this one holds the keys to your awareness. This is the version you're conscious of. This is the version you can shape. This is the version you can elevate. It's a powerful shift in perspective. We're used to thinking of life as a fixed path, a sequence of causes and effects, a straight line from beginning to end. But the quantum view reveals something more dynamic. Life is a branching algorithm of possibility, sculpted by your interaction with the unknown. You're not merely walking a road, you're generating it beneath your feet as you move. So what does this mean practically? It means your choices matter not just in a moral or social sense, but in a foundational sense. It means each action you take becomes a defining moment that determines which universe you continue to experience. The possibilities don't vanish when you choose, they unfold somewhere else. But this path you're now on, becomes more defined, more tangible, more yours. And there's something else this knowledge gives you, a deeper sense of responsibility. If every choice you make selects a version of the universe you continue to live in, then your internal state matters more than ever. Your attention, your intention, your thoughts, all of them become the architects of the reality you experience. Not metaphorically, but at the level of actual physical emergence. When quantum researchers speak about probability amplitudes, they're referring to the weight of potential outcomes. But those outcomes are not chosen by randomness alone. They're chosen by interaction. In your life, that interaction is your consciousness. Every time you choose to notice something, focus on something, believe in something, you change the amplitude of potential futures. You shift the scales of what becomes your world. So ask yourself, what future are you weighting with your attention? What reality are you reinforcing with your beliefs? What possibilities are you collapsing into form through your choices? That is the real challenge of understanding quantum reality. Not just learning the concepts, but living them. Not just recognizing the multiplicity of possibilities, but responding to them with awareness. And when you do, you stop being a victim of circumstance. You stop being a passenger on some predetermined train. You start becoming the conscious selector of your own universe. This isn't mysticism. This is the logical conclusion of what quantum mechanics suggests. You are not a static being in a solid world. You are a conscious fluctuation in a fluid matrix of possibility. You are not observing reality from the outside. You are participating in its unfolding, moment by moment, choice by choice. And this brings us full circle, back to the question posed at the beginning. Are you living all possibilities? The answer is yes and no. All versions of you may exist across the quantum multiverse, but you are only aware of one version, and that makes this one immeasurably important. You are not everything at once, you are this now. You are this strand, this choice, this moment of consciousness navigating the infinite. So now, it's not about whether infinite versions of you exist. It's about what you do with this version. Because in the grand theater of probability, this moment is your stage. And while other versions play out unseen, this one holds your awareness. This one holds your agency. This one holds your power to shape. That is the ultimate insight quantum theory offers, not just to physicists, but to anyone willing to ask deeper questions. The universe may be infinite in possibility, but you still have to choose how you show up in it. And that choice reverberates through everything. So, next time you hesitate to act, next time you question your impact, remember, you are not a passive character in a single story. You are a quantum participant in a multi-layered reality, choosing which version of the universe becomes real with every thought you think. And if all possibilities exist somewhere, The real question becomes, what will you make of this one? Because this reality, this life, this version of you is the one you're aware of. Make it count.